Hello and welcome back to my channel. My name is Piyush. This is day 46 in 40 days of CKA series. In this video, we'll be looking into pod priority and preemption, including the priority classes. What are these and why it is important? This is one of the new topics that were added recently in CKA series in 2025. So I thought of covering it as well as with the help of demo. So in this particular video, we'll be looking into what exactly is a pod priority or a priority class and how does preemption works, what is preemption and so on. Then we'll be also doing a demo of explaining it end to end, like how priority works, how preemption works, why it is important. And this will be covered as part of an assignments in the GitHub repository. Then you can practice yourself and follow along. Okay, so let's try to understand from a high level what exactly is priority and preemption. Okay, so let's say a user over here, he or she creates new pods, new application pods. Initially, the pods will be in pending status. Considering this is a resource constraint environment with limited number of resources or most of the resources that have been already occupied, so the pod will be in the pending state until it gets the resources. Now scheduler has to wait till the resources are available, right? So scheduler keeps the pods in pending status, or it can also kick out the existing pods to make some room. Okay, so that's also called pod eviction or preemption. Okay, so that means to uh, schedule some high priority pods or some critical pods, some low priority or non-critical pods has to go out from the server to make some room. Okay, so it happens the same way, like you are standing in a rally and then some VIP comes or VVIP comes, you get kicked out of that meeting room or the rally to make the room for VVIP. So these high priority pods are the VVIPs, are the VIPs. Okay. And there are certain decisions that scheduler has to take, like which pod to evict. Okay. And that's like I've told you, it's called preemption. And then which pod to be scheduled first, and then which pod to be scheduled after that. So that's totally based on the priority. Okay, so let's assume VVIPs gets the highest priorities, then VIPs, and then general public. Okay, so that's how the priority works as well. Okay, so first the high priority pods, then the medium priority, then the low priority, or if we have more classes. Now these priorities are defined in the same way, like starts from zero and it goes up to, I guess, 20 billion or something, so it has a higher range. But if you see the numbers like this, so it goes from 0 to, let's say, the 0 has no priority, or which is also the default priority, then 200, 5,000, 10,000. If you have anything 20,000, that will take the higher priority than this one, and so on. Okay, so it goes from the lower number to the higher number. Higher the priority number, higher the priority, as the priority says. Okay, now to map a particular priority with a value, we create priority class. Okay, so what do I mean by that? So let's say we have three priorities. One is 1,000, another one is 10,000, and another one is 1, 2, 3, 4. Okay, let me see how many zeros are there. 1 million. 1 million or 100,000? Yeah, it's 1 million. Okay, so 1,000, 10,000, and 1 million. Okay, so this will have the lowest priority, this will have higher priority than this one, and this will have the highest priority. Now how do the pods or how do the workload know that which priority to use? Okay, and like it's not really a good practice to hard code this priority number in each and every pod or workload. So that's why we create the priority class. Okay, so in priority class we provide the details such as the priority value, which is this one. Okay, priority name, which is, let's say, low. It has some additional fields such as Global default meaning, is it the default priority for every pod that's gets created without the priority class? So let's say the lowest priority class will have the global default true. For these two, it will have the value set as false. So that means this priority class is the default one. These two are the non-default ones. Okay. So if you create a pod without specifying a priority class, it will by default get the low priority class. Okay. It also has the field such as preemption policy. So if you don't want to preempt any low priority pods, and it only works when there are multiple pods of different priority class running, so then we said preemption policy as never. Okay, so let's take this example. Okay, so we have a node. So this is, let's assume it's a one node cluster. Okay, it has 16 cpu and 256 GB of memory. This is a Kubernetes node. Okay, with some limited resources, 16 CPU and 256 memory. Now it has three pods running over here, pod 1, 2, and 3. And these pods are using 4 CPU, 8 CPU, and 3 CPU. So that's 4, 8, 12, and 15. So 15 CPUs are already being used, and total was 16. So that means only one CPU is left, and there is some CPU that's been used by them, some system components as well. So let's say we have less than one CPU left for any new pods to be scheduled. Now if we create a new pod, let's say pod 4 with 4 CPUs, it would stuck in the pending state. Okay, now till when it will stuck in the pending state? It will stuck in the pending state till a lower priority pod is evicted. Let's say this one or this one or this one, any of these are evicted, only then this will be scheduled. Now it has to be higher priority pod than any of the running pod to evict the existing pods, right? So if it is a low priority pod, then it has to wait. And if it has the high priority or the medium priority, then low priority pods cannot evict the high priority or the medium priority pods, right? And these are just the examples that I'm giving, like low, medium, high priority. You can have as many as priority class as you want. Okay, so you could have, let's say, priority 1, priority 2, priority 3, or you could have, like, let's say, lower class, middle class, upper middle class, first class, business class, and so on. So whatever you want, you can set as the priority class. Okay, so that's the basics of priority class, preemption, and priority. So let's dive into the demo now, and let's see how it actually works. Okay, so if you check the GitHub repository as well, you can see this is the assignment over here. Okay, create 3 priority class with different values, with different priority values. Deploy pod with different priority class. Create a resource constraint deployment with 5 replica and resource request set. Check your node resources to make sure that you create a new pod which has a higher number of CPU or memory requests, and then you observe the preemption and document your observation. Okay, so let's try to do that. Let's try to do this demo. Now you can use these free labs as well that Code Cloud provides. So it has these 7 labs for the newly added topics. So if you want to use this lab, you can use this by clicking over here, enroll for free. I will provide the link of this um, in the description section, or you can also use any of these playgrounds, or you can have a mini cube installation, or if you have a Kubernetes cluster, you can test it over there. Doesn't matter. Okay, for now I'm using this for the sake of simplicity. I don't want to create the cluster. I have installed it multiple times. So I've actually started a different lab. What I need was priority class. Okay, so let's say and refresh, because at a time you can have only one lab session. That's the rate limitation that they have applied. It's good. So you can practice with the already provided uh, lab assignments over here. So for example, like you can follow these 11 tasks and select the best appropriate response, or you can follow along the task that I have provided you. It doesn't matter, you just need to practice it enough. Okay, so I'm gonna follow the one that is there in the GitHub repository. Okay, so let's see if we have any priority class, kubectl get priority class or PC. So we have two priority class, system cluster critical and system node critical, with these values global default as false. So we don't have any default priority class created already, and preemption policy is preempt lower priority. Okay, so this is the default behavior, like um the lower priority pods will be preempted. Okay, now as part of our task, what we'll be doing, we'll be creating three priority class with three different values. Okay, so for that, let's try to understand the YAML format of priority class. So if I do kubectl explain priority class or PC, it should show you the different fields. So fields, it has group, which is scheduling.kh.io. Okay, and the version is v1. So that means the API version is scheduling.kh.io/v1. Okay, I'm just gonna copy it from here. And then kind is priority class. Then instead of spec, it has different fields such as description. Okay, it has okay, so this is part of this. It has global default, whether it is true or false. And then it has metadata. In metadata you have name. Okay, so name comes under metadata. It has a preemption policy, it could be never or preempt low priority. Okay, I guess these two, and it defaults to preempt lower priority. This is the default. Then it also has a value, which is the required field. Value is the value, the integer value of the priority class. Okay, so if I just do p1.yaml for the first priority class, okay, it starts with API version colon scheduling k's io/v1. This we have already seen the format. Okay, and then the kind is priority class with C capital. Then we have metadata. Why it is doing a tab? Okay, metadata will have name. Okay, let's give it a name, high priority. And then it should have a value is the mandatory field. So let's use 1 million 23123. Okay, and then global default with D capital, which is in camel casing. Let's keep it false. We don't want high priority as the default priority. And then we have a description. Let's give this priority should be used for high priority pods. Okay, and then let's save it. Preemption policy, by default it's set to preempt lower priority, so I am not setting it because it's an optional field and it has a default value. So let's use this one. Save this, and I'm gonna just create two copies of it so that we can just make the changes over there. p2.yaml. Okay, and let's create one more, cp p1.yaml, p3.yaml. Okay, let's open p2.yaml and let's change this to medium priority. Okay, and value is 10,000, and let's keep the global default as false. Similarly, open p3. Let's change this to low priority and value is 1000, and let's set this global default to true. Okay, and I did not change the description, so let's change this as well for low priority pods. Okay, now let's apply these changes. Kubectl apply -f. If you do a dot, it will apply all the YAML in the current directory. So that's what I did. Now let's clear the screen. Kubectl get PC. So we have our three priority classes created: high, low, and medium. And the low priority is the default one. So now what we need to do is we need to create some pods that consume these priorities. Okay. So let's create a high priority pod. I'm just gonna open pod1.yaml. Okay, so this is the high priority pod, nginx pod with 128 mi of memory, 500 mi, 500 m of CPU, which is point 0.5 CPU. Priority class name is high priority. Okay, so rest everything is same. It just this additional field has been added inside spec of the pod. Okay, to this kubectl apply -f pod 1.yaml. Okay, if I do kubectl get pods, so it should be created soon. Okay, it's running now. If I do kubectl describe pod, let's do a describe on this. Okay, it has been created and you will see the priority set over here somewhere. This is the resource request, and you see the priority has been set as this one, 1 million, which is from the priority class name this. So we did not set this field inside the pod, we just pointed it to the priority class name and it did the mapping internally. Okay, so let's delete this pod. Delete pod. What was the name of the pod? Let's do a get pod kubectl delete pod. Okay, now what we can do is we can create a resource constraint environment. Okay, so I'm just gonna create a dummy deployment now. So deploy.yaml, and this deployment is requesting 256 mi of memory, zero point 0.5 CPU, and it has 5 replicas. So this particular requirement is for each of the pod. So we have 5 pods, that means it will use 2.5 CPU. It has 5 pods, so it will use around 1.25 GB of memory. Okay, and all of them will be low priority pods. So let's save this and let's apply this kubectl apply -f deploy.yaml. Now let's quickly check the node. So it only has one node, which is a control plane node, and let's check the resources of this node. Kubectl describe node control plane. Okay, and it has, let's say, okay, over here it has 16 allocatable CPU. That means 16 is the maximum CPU that it could have. Some of them might be used by some system pods, some control plane pods, and so on. And how much is the memory is this one in KI, so you can convert that. It could be, okay, I'm not sure, you can convert that if you want, but we can play around with CPU now that we know 16 is the maximum limit. And we have kubectl get pods, so 5 pods running, each of them will be using um, zero point 0.5 CPU, so 2.5 CPU has already been used. Now what we can do is we can create a new pod, okay, with high priority. Okay, and we can use, let's say, okay, first let's see how much is the pending. If I do kubectl top node control plane, oh, metrics are not available, that means metric server is not running. But anyways, it would only have like 13.5 GB memory left. Okay, or 13.5 CPUs left, or 12.5 CPU left, something around that, so less than 12. So now what we can do is we can create a critical pod. So let's call it cr.yaml. Okay, and let's use the priority class as high priority. Memory, you can use anything, and let's use 15,000 M of CPU, that means 15 CPUs, so that it should kick the existing low priority pods. So let's do that. Save kubectl apply -f cr.yaml. Okay, and get pods. They all are in pending state. Oh, it says container creating. So that means it already kicked those ones, right? Um, if you want to observe the preemption, you can run kubectl get events and you will get the complete picture. So it says it's scaled up 0 to 5, but it does not show any preemption. Okay, so it says over here one node. Did it create a new node? Get nodes? No. Okay, it says it scaled up the replicas from 0 to 5 for the resource hog, which is the previous deployment we created. And then we created a critical pod, but earlier it has insufficient CPU. It says 0 to 1 nodes were available. Then it created it, and then it created the pods and everything successful create all of these. If I do kubectl get pods, so you see it created all those, but it's still there in the pending state because this one has the higher priority. Okay, and let's delete this one, kubectl delete pod. Okay, and now let's do a get pod. Now you see, as soon as I deleted that pod, it started this particular containers of all the pods. The all the other pods are running. Now if I apply the changes again to the critical pod, let's see what happens. Get pod hyphen o watch, oops, hyphen watch. You see all those went into pending state and it started the critical nginx. Why? Because critical nginx has the higher priority. The lower priority pods has to be kicked out to make room for the higher priority pods. So kubectl get events. It does not show the preemption, but it should show. Oh, okay, over here. You see, first it says created, started, those pods were started. Okay, and then it says preempted. The pod resource hog was preempted by pod this on node control plane. So this is the system critical, the pod that we created with the higher priority. So it shows what's been added, what's been preempted, and you can sort the event as well by hyphen sort by equal to dot metadata. So this is, if you have watched the JSON path video, in this I have covered this section, like how do we um, run these queries or these kubectl advanced commands, right? So I'm gonna sort it by metadata creation timestamp. Okay, now it's sorted. So it says first failed scheduling. Okay, and then it was scheduled, pulled the image, and it created it. But earlier it did not have any particular node resources available, but it preempted the resource, and at the same time it was trying to schedule. It was failed, but then as soon as it has some resources available, it was able to schedule that critical nginx pod on the node. Okay, so that's how a pod priority and preemption works. Now, if you are using a local environment, you can perform the cleanup. Okay, and if you are not using the local environment, if you are using the sandbox, you can just close it and that's it. That's just be done with it. So, yeah, thank you so much for watching. I hope you found it helpful. I hope you found it valuable. And let's catch up soon in the next video. Thank you.